Delivering the last mile. How can innovative trailer design improve efficiency? Ideas for store and home deliveries are evolving quickly. Speed and efficiencies for freight distribution in the last mile have become hot topics and priorities for success in servicing fast-growing companies like Amazon as well as local distributors like beverage or auto parts. What does this mean for truck trailer design and safety now and in the future? So I'll let Dave introduce himself and the rest of the panel, and we'll get started. The panel will be about an hour long, and hopefully there'll be plenty of time for questions and discussion at the end, and we encourage you to participate, and we look forward to it. Thank you all very much. And by the way, Kenny, where are you? Kenny? Kenny, no, that's Kenny. And then this Kenny Gleason is the guy that's been putting together the slides and running the show, and I don't know where we'd be without him. So thank you very much again. Appreciate it. Okay, Dave, it's all yours.
Thank you, Charlie. So we're the first, I guess we're the first panel, so we can't do it wrong. There's nobody to compare us to yet. So we have four distinguished panel members. I'd like to thank you for showing up, and thank Strick for inviting us to come and talk about an interesting topic. Format a little bit, we're going to each of us do a little short presentation, tell you a little bit about who we are and what we do, some of the innovative things that are going on in our worlds, and then we'll open it up for questions at the end. So we'll sort of hold the questions until the end. I'm going to start off, and then Mike Palmer from Estes is going to talk a little bit, and then Bill Whitmauer from Loading Automation down at the end, and then Greg Ellis from PDC, and then Dick Sullivan will bring up the end. And so that's sort of the format of what we're going to talk about. So let's see if we got a... So some of you might wonder what the last mile is all about. When Charlie first mentioned that, first thing that came to my mind was the movie, the Green Mile with Tom Hanks, if those remember that. And I'm hoping that's not where we're headed when we go on the last mile. Yeah, when we go on the last mile. So more than likely, I thought about the Green Road. I mean the yellow brick road that Dorothy followed. But the question is it the past or is it the future? And so I did a little research on the internet, and there's a lot of talk about the Amazon effect, more efficient deliveries, but that's not necessarily a new concept. If you think about grocery store industry, the liquor industry, places like Chicago, where I come from, when you deliver the liquor to a local bar, you collect the money before you leave, because he may not be there tomorrow. So you got to get your money. But you think about the grocery store industry, they've been stocking shelves, doing inventory for years in that business. So there's some industries that have been doing this kind of stuff, really for quite a while. And we're looking at, what kind of new efficiencies there might be in the system, to make this final delivery. So this is an interesting delivery vehicle. This is what UPS used to use to deliver packages. I don't know if any of you have been around long enough to remember those. I don't. So this is what UPS is looking at today. Not a lot different than what they were doing way before any of us were in the industry. So this is an electrically assisted, three-wheeled package delivery vehicle. So the question is, for people who make trucks and trailers, if you're going to have 2 or 3 of these to go along to deliver packages, where are you going to put them? How are you going to get them off and on the truck? So here's another interesting, UPS claims to have the first alternative fuel fleet in New York back in 1933, probably before almost anybody in the room was born. Interesting. So here's the latest alternative electric vehicle for delivering packages. Again, if you're going to carry, if you think about a truck as a moving warehouse full of packages going up and down Main Street, I could visualize you take 2 or 3 or 4 of these along, and they do sort of a hub and spoke and deliver up and down the side streets. Where are you going to put this thing on your trailer or in the back of your truck? How are you going to get loaded and unloaded? And it says the top can be removed. So what do you do with the top when you take it off? You going to throw it in the neighbor's yard? Where are you going to put the 3 or 4 guys that drive these things? You got a truck driver and you got 3 or 4 of these guys. You can't put 4 or 5 guys in a truck today. So there's some interesting concepts that are going to impact the configuration of trucks and how if some of these things take off. Now, if you go to a drone, you can land that on the roof. You got an overpass problem in Chicago with all the elevated subsystems. It won't fit under there, but there's some interesting concepts. So to give you an idea of some of the things that Amazon has done, they cut a deal with the U.S. Post Office to deliver on Sunday. Post Office never delivered on Sunday. Now they're delivering on Sunday. They also do same-day delivery. I get packages from Amazon on Sunday morning, ordered on Saturday. Amazon putting lockers in stores around town. You now can get an email with a code. You go pick up. You go to the store. You put your code in. It pops the locker door open, and you get your package. So now, the last mile delivery is actually the customer going and getting the part or the piece that they wanted. They're also looking at Uber using them to deliver packages. There's a little independent garage downtown Chicago that I see that runs 24 hours a day, 7 days a week, repair primarily taxi cabs. They have no inventory for parts. They're fixing cabs all the time. They have no idea what cab's going to show up and what's wrong with it. Another cab shows up, gives them a package, they give them the money. So there's people delivering parts to this little 2-stall garage 24 hours a day, 7 days a week to fix taxi cabs in Chicago. So what's next? You got the drones, you got the robots. So according to the research study, actually the U.S. Post Office delivers more Amazon than anybody else. They have 40% of the Amazon business. UPS only has 20 to 25%, and FedEx only has 20%. So today, Amazon is probably the salvation of the postal system. So what's next? So I think about the next headline that you might see on CNN or on Fox News in the morning. Trump's going to sell the Pony Express to Amazon. You don't think that's possible, huh? He can do almost anything today. So, but it's not just, if you look at some of the research, it's not just delivering the package to the front door today. You deliver it to the house, but now you take it inside, you unpack it, you inspect it, you remove the debris. But that's not really all you're going to do with people who are advertising white glove service, and there's several companies who are doing this today. They set up, they install, and they do assembly. So this is what your driver's going to be doing. He's going to be assembling something came from Asia with instructions that are encrypted, written by somebody who's not very good at English, probably doesn't know the difference between a screwdriver and a crescent wrench. So your truck and the freight are going to be sitting in the street, and your driver is trying to figure out how to put whatever it is together and hook it up and make it work. And Ken was just, who was with me, was telling me the story. He had this happen of a washing machine. It didn't work. He calls these people, and they say, sorry, we don't fix if it doesn't work. We just installed it. So you got an unhappy customer because you installed something and set it up. It was supposed to work. It doesn't work. And now when the wife says, you go, sorry, not my job, not my driver's job, and you walk out. All right? So we have Mike?
Good morning. I'm Mike Palmer from Estes Express Lines, Vice President of Fleet Services. And before I get started, I'd just like to say that we like strict trailers. Hold the card up so I can see it, Charlie. We bought a lot of trailers from these guys over the past 10, 15 years, and they do a good job for us. So, had to get that out of the way. That's one right there, actually. Can y'all hear me? I couldn't hear. I guess I need to stay in the range of the microphone. So Estes Express Lines, founded in 1931, largest privately held carrier in the United States, North America. It's owned by the Estes family. We're in the fourth generation. They're good people, good company to work for. We did over $2 billion in revenue last year. We have over 16,000 employees, right at 9,000 drivers, 6,500 tractors, 27,000 trailers, and around 216 terminals. So Charlie had called me a couple of weeks ago and said, hey, I need you to do a little presentation. And I said, well, Charlie, if it'll help you sell trailers, I'll be glad to do that for you. So I told my wife I had to go to Fort Wayne to do a presentation and to look at some trailers at the plant. She said, well, what's the topic? And I said, it's final mile. And she said, what is that? That sounds kind of like a retirement plan or some kind of like a death march. And I said, no. I said, it's residential and home deliveries. But then I got to thinking about that, and I thought, well, gosh, that could be misconstrued too. So, although the term final mile probably fits for both these, it's more like this. And we've been in the final mile business probably for 15 years in some form or fashion. A lot of experimentation went on. Last year we delivered over 800,000 residential deliveries. We are in 40 markets. And that's growing weekly. Our customers, some of the bigger ones, are Home Depot, Target, Toys R Us, Walmart, Amazon. Our average shipment size is 350 pounds. A lot of it's, I think, over 50% is still palletized. So as I was thinking about this topic, I was like, okay, what are the customers expecting? And so obviously everybody wants free shipping, I do, and most customers do, but that's kind of challenging for the transportation industry because you have to price this stuff to be able to make some money off of it. So that's one challenge. Same-day service, scheduling and appointments. I know in our area in Richmond, Virginia, Amazon had a deal where they would, if you ordered it, they'd have it there in 2 hours. So that's pretty good service. And of course, goes without saying, damage-free. So currently, this is what I call the equipment of choice in terms of delivery, and I think the market kind of dictates where you're going to use these vehicles. So the step van, the straight truck, the light-duty van, and some of the E350 type vehicles are what people are using. And then when you start thinking about the environment that these guys have to operate in, there's lots of different scenarios. And I think with technology, we'll be able to kind of dictate where those trucks need to operate and what type of equipment we need. So I just took a few snapshots here, and you've got situations where you have, a lot of people but no place to park, and then you have these neighborhoods where you have cars on the streets and low-hanging trees that are potential targets. Some other challenges, you got kids that play in the street. That's certainly a big issue in terms of safety. And then again, you have neighborhoods, tight streets, power lines. So a lot of challenges as far as the neighborhoods go. But then there's also the neighborhoods that, you know, have underground utilities, a little more spacious in terms of the road size and the driveways and not much of the parked cars and a little more room to maneuver. So as we looked at this, I was thinking, you know, is there a way that we can use a trailer to do final mile? And I guess that would probably depend on the situation in terms of the neighborhoods. But it would take something a little different than obviously this type trailer. So as I thought about that, you know, some of the qualities or specs you'd probably have to have on one of these trailers is you'd have to have cameras so that you could, like your backup cameras in your car, and easy in and out for the driver as far as the trailer, multiple access points, maybe even low to the ground where you didn't need a lift gate. Security, the guys making a delivery, there's good neighborhoods, bad neighborhoods. Visibility, you know, and I thought about this in terms of when daylight savings time comes, you know, it gets dark at 5 o'clock, so you're going to have to be able to see inside the trailer and probably need lighting outside the trailer. Dock height might be an issue here too. In terms of loading the trailer, depending on how you design that. But if you're able to use a trailer for this kind of work, you've obviously got more capacity, and depending on, again, you know, how many stops and the volume you have in that particular area, you got a rolling billboard. In some cases, a trailer and the tractor could be less expensive, especially when you break it down into dual utilization. And then again, the flexibility of being able to use the tractor for other things instead of just final mile. So I etched this out last night. No, actually, Charlie and Justin and I have been kind of talking about a trailer, a pure P&D trailer type concept. And so the idea here is that we were looking at a drop deck, doors probably on all sides, including the rear. Maybe it wouldn't be a tandem axle. It'd probably be a single axle. Ramps, and then possibly the hydraulic system so that, you know, loading it from a standard size dock is going to be a problem. So somehow to get the back end of the trailer back up to the height of the dock, but there's some issues with that have to be worked through too, because you got the front end to deal with also. So that's kind of the concept that we're kind of playing around with. Here's some other information that Justin put on there. So, but I think the important thing is that as the freight industry changes, you know, we need to be constantly asking ourselves, how is what we're doing as far as equipment the best way to do it, or is there better design, something more efficient, something better for the driver, and makes it better for everyone? So, thank you, guys.
Thank you. So now we got Bill's up next? Yes. All right.
So I'm the guinea pig? Yeah. Okay. Morning. Oh, that sounds louder already. I can even hear that. All right, next slide. I can't move. got to be the donut. Somewhere where it doesn't scratch. How's that? Great. Wrong one. Yes, that's the one I hit. There we go. Who am I? Okay. Loading automation, basically, what we do is helping everyone in this room and the customers try to improve their vehicle loading and unloading processes. That's kind of what our main forte is. Everybody has the product, everybody has the manufacturing, everybody needs to get it delivered to the customer. What we try and do is look at all the variables and come up with solutions in order to help increase everyone's bottom line and doing it efficiently, and also reducing multiple handling, a lot of product damage, things like that. Always done with safety as far as our main job one. We've done it many different ways over the years. We've started with roller systems. That's probably the first one that was done back in the 70s with the air cargo guys, as far as what we were involved in. We do retractable roller systems that are installed in transport vehicles, trucks, trailers, basically to handle air cargo containers, which the airlines were already ahead of the game trying to be more efficient as far as how they handle their goods. So they come up with their standard box size, put it on a cookie sheet that you can roll it much easier, and then take that into the same concept as far as how it's loaded and unloaded into the vehicle. You've also had that come through with a lot of sea container operations. They're looking at it as well as far as how to be able to load and unload more efficiently out of sea containers, because obviously goods move in a lot of different ways, whether it's trailers, truck bodies, jets, or sea containers. The main thing we try and do is improve and reduce the customer's material handling processes. A lot of times, obviously, right at the loading dock. That's kind of our interface, our missing link, as far as how do we handle the product and make it more efficient to get it in and out of the vehicle. Again, safety is usually our job one. Now again, air cargo was the first type of application that we've seen as far as a lot of different types of handling and being more efficient. You have FedEx, UPS, DHL, Forward Air Freight, Columbus area. You also have Amazon, obviously, is very much in front of everybody's boards these days as far as how they handle products with their delivery processes to the customer. They've gone to a point where they needed some additional resources, so they went out and bought their own cargo jets. So that was quite interesting. Typically, again, in air containers for the air cargo shipments as far as how it's done. A lot of it used to be hand loaded and unloaded, so the idea was how do we improve this process? So that's where the idea of the roller system in a vehicle came into play back in the 50s to the 60s, initially with live rollers, and there would be inherent issues with that on how to secure the product down in transport of that. So we came up with the retractable roller type design so that once it's rolled into the trailer, you drop the rollers. Again, safety, to keep the product in a static load position. And then on the second side, or on the right side, we also have done it with consumables. Anheuser-Busch, Miller, Coors, Procter & Gamble, Clorox, anybody that's taking a lot of volume of product, in this case from point A to point B, which would be from their manufacturing facility to a distribution center. That would be one of the things. So typically done with a forklift operator after the product's brought out to the loading dock door. Forklift operator takes 25, 35, 40 minutes to load a trailer. What we've done to try and improve the efficiency of that is you stage the product on a conveyor coming right off the palletizer. You do the same in the trailer, and instead of a 30 to 40 minute load time, now you can do it in 2.5 minutes without a forklift touching it, interfering, creating any kind of, you eliminate a lot of the double handling. And then you do the same thing at the unloading end. That's a lot of the breweries were very quick at doing that back in the 70s for new cans coming into the plant, new bottles coming into the plant, where now you can automatically load it into a vehicle in 3 minutes, take it down the street to the brewery, unload it at their receiving lines in 2 to 3 minutes, go back and get another load. So it's very, very efficient for a lot of products that are done like that. Similar applications regarding how to do it a little better. You have a lot of automotive accounts that obviously are involved in that as well. Some examples here show tire and wheel assemblies. A lot of times they're just done, they started out having the tire and the wheel being at the manufacturing facility, at the car manufacturing plant. They've now improved the process where it's a secondary building at the facility. They've done it a lot more efficiently, where they will now build in sequence to what the line production is, and they'll call out as far as what the type of vehicle is, the type of wheels and tires that it gets, and they supply these, stage them on a loading conveyor the same way, and then take that, again, load the trailer in 3 minutes. You basically have 1 hour's worth of tire assemblies on the trailer, about 60 cars worth on that, and it's loaded in 5 minutes. They go down to the plant, they unload onto the conveyor, same way, in 5 minutes, same trailer comes back. So it's just more efficiency as far as handling the product, getting the product to the customer, driving the bottom line, making a better profit. The right side was a Harley-Davidson application where initially they were delivering bikes in boxes. When they delivered it to the Harley dealer, he received a box. They had issues with that. There was no guarantee on what the product looked like on the inside of it. The box was typically unpackaged by a part-timer at the plant or at their facility, at their dealership. Dealer, issues with once they unloaded it, whether the guy created some damage while he was unloading it, scratched the chrome, things like that, created a lot of issues. So they needed a better way of delivering the bikes to the dealers, so we came up with a design regarding a double level system that basically now, instead of the 13 motorcycles, they can get 30 of them in the same trailer load and doing it a lot more efficiently. Other applications where customers have looked at that are cans to the trailers in a vehicle that's going to the same breweries. The next kind of evolution that we're talking about here is, instead of having the rollers in the vehicle itself, there's simply an unloading mechanism that allows you to unload these right onto the dock without the need of a roller bed type of a trailer anymore. So the evolution is kind of moving up as far as how processes are done, again with a lot of thought regarding the product itself, as far as what do we want to see. What this gives them is the ability to take a trailer, non-dedicated trailer at this point without any type of roller equipment, design an unloading system basically to automatically unload that trailer without having the need of a dedicated trailer that has to be tied into that route. On the right side, you see kind of another vehicle, which is a Sprinter, the smaller delivery type vehicles. We've done some of that, again, within the beverage industry, just-in-time industry, pharmaceuticals, where, again, their thing was how do we get the product into the vehicle and out of the vehicle safely in order to improve their efficiency with less damage. What they've done here is typically you can put 3 pallets in between the wheel wells of a Sprinter. The old method was you set the first one down and you push it with the forklift. And then you bring the second pallet behind that, and you push it a little further, third one the same way. Well, that's not necessarily the best for the product or, potential damage to the vehicle itself. And then when they tried to unload, you hooked it or attached a rope or a chain and you drug it to the back of the vehicle, the same thing where you get potential damage. So they've also come up with other types of handling systems to do that, where you can simply install an unloading system to be able to bring it to the back so you can safely load and unload that. There's also similar applications, and a lot of that has been done in Europe. Maybe 10, 15 years ago. They're a little further ahead on some of the automated material handling type systems because of their higher cost of operation over there. We are looking at a system now that can also automatically load an entire trailer without the need of any type of conveyance within the trailer itself. You stage it on the dock, and basically that entire load is rolled into the vehicle itself. There's a bar that's placed on the end. You remove the loading device that's underneath that, and you can totally load a non-dedicated trailer within about 4.5, 5 minutes. So that's kind of the next generation as far as material handling is, especially over here. We have a lot of 3PL carriers that have a lot of high volume out of their warehouse or from their shipping dock doors. And instead of having the forklift operator that's doing all the loading and unloading, he'll just stage it on that loading conveyor dock. And then this does not require any modifications to the vehicle. It can be any trailer. So that's kind of the next generation to material handling, is more efficiency on the outbound side for the throughput to get it out the door without having the need of trying to automate a trailer. There's no need for that anymore. So it's kind of the next phase as far as automated truck loading and unloading. And again, that's just basically my calling card in reference to where we had started back in the 70s when we had started with the air freight, the roller guys, and now we're into the non-dedicated type of loading systems. Thank you.
Everybody hear me okay? Works on electricity. There you go. How about now? So, as we get loaded up here, it's 9:33. Dick and I have 12 minutes plus questions and answers, so I'll step through it as lively as possible without slurring. My name is Greg Ellis. I'm with PDC, which is actually an engineering consulting company in the supply chain field. And Charlie called me just a few weeks ago after hearing about invention or innovation that we have come up with and saw it at one of the trade shows and asked me to speak. So I have a little bit different perspective in that I'm not in the trucking business and I'm not an end user. I'm not a supplier of parts. I'm that company that people hire to solve their supply chain or come up with some supply chain solutions. So effectively, we design factories and warehouses, all the way from filling and, manufacturing to the store shelf, which was a great lead-in earlier. And the fastest growing part of our business has been this direct store or direct address delivery. So we've been working with beverage companies, food companies, auto parts, pharmaceuticals, things like that for direct store delivery really nonstop. Including, as I stand here today, I've always got somebody at PDC out on a route truck, doing time studies, doing deliveries. So this is just a smattering of what we do, but the important thing is we're an independent company, so it doesn't matter to PDC what the answer is. As long as it's financially justified and can be backed up, that's the answer. We get our fees from our clients, and then they tell people. So we're completely agnostic as far as what the answer is, and we're an operations-based company. We've all done the job, and I don't mean, back when I had that fabulous blonde-haired butt cut, that everybody had. I mean, I was picking cases just a couple of days ago, right? So everybody at PDC is always out there on the shift or on a truck loading or unloading as part of our studies. So what we came up with was all this math that we were doing, we could produce it pretty efficiently. We could store it efficiently. We could package it. We could load it on the truck efficiently. We could get some cube utilization on the truck. And where the supply chain came to a screeching halt was at the deliveries. And I had someone say the other day, hey, I've been to their DCs. They're putting hundreds of $millions in automation and sortation and packaging and palletizing, and then they put it on that same truck. That same truck. So the math kept coming up with, we need another alternative. So we were trying to find an alternative that basically brings the goods to the delivery person. And when we showed it to people, they were like, finally somebody did something for the driver. Okay? So previous attempts, and these are a couple of beverage examples, the traditional side load truck, and you can see the problems with the side load is you can only get to the cases that are on the top of the pallets. So as people started offering more SKUs, they needed more tops. So the trucks got longer and longer and longer. That truck there has got a 2,000 case capacity. It's got about 450 cases on because there's no selectivity to it. The side load job was so horrific, whether it's package or products or beverage, that people started going to the end load truck, which certainly has a play, but it depends on what your drop size is. And so they're riding up and down in the elevator. They go in and out of a truck, and it's still person to goods, just like someone's got to dig. The interesting thing about whether it's a UPS or FedEx or Ready Ice or all these different things is for every case that's delivered, they handle 2.5 cases, 2.7 cases, depending on the customer, because they're digging. So you can say, this is how many cases I want to get off on a route, but that's not how many cases they're actually touching. So all of our math kept coming up with service time. What's the optimal service time? We want to run out of service day, not capacity on the truck. So what it called for, and this is just some test units that we built that actually could be put into a side load, and they're just a modular unit. What we came up with was something that would bring the cases forward and down. Cases, kegs, T-shirts, whatever the case is. And you can see it's a combination of vertical and horizontal movement, taken with the iPhone, by the way. Sorry about the jittery thing. But we're no longer bending. We're no longer climbing. If anyone knows about this type of product, it's 32 to 35 pounds, 38 pounds per case, and they stand on the lip and they reach up and they grab it. The primary injury at the stops is shoulders, not back, because they're swinging the case down while they hold on to the handle. This is a situation where a keg of beer, it's about 165, 170 pounds. All the kegs or cases get brought down to the waist level, and with a little adaptation here, you put a little metal slide there, you can slide it right onto your two-wheeler. Yeah, those are empties. I'm not that strong. But you get the picture. So you get a better cubic utilization of the truck, and all the work of retrieving the product is done for the driver. So as manual, as primitive as this may seem, two people with the old-fashioned pneumatic wheel two-wheeler can outstrip a lot of different delivery vehicles for speed. So what we did is the math sort of had an intersection. And it said, we can get more cases on the truck, but it doesn't matter because I can't get more stops off. When you reach the point, when the customer reaches a point where they can't get more stops off, that's the end. So what we needed to do was decrease the time at the stops. And we do salesman routing and merchandiser routing. Should the guy delivering be merchandising? Should we follow up in a Prius with a merchandiser or separate merchandiser? Should there be a super salesman? We do all the financials and all the time studies to determine these routes. But what always fell apart was at the stop. So what does it look like in the warehouse? Well, we did all the math and the financials based on the first one where you pick it to a pallet and pick it again. Unlikely. Very simplistic pick the belt where we can manually stack it, and really anybody with any amount of volume probably would look something like this with a simple squaring station, and then we'll load the truck on a combination of the vertical and horizontal movement. Obviously the shelves can go up, they can go down. The belts always protrude through the bottom of the shelf. So effectively, this would be a truly geographic truck where you could deliver at dock height and you could deliver up and down the street. Okay? And I know I'm going pretty fast, but I'm doing the best I can. So what we struggled with was it was either a lot of pack out or a lot of selectivity. We had to have one or the other. We could floor load a trailer, but it took forever to get the stops off. We could put all these half pallets on there to be fast to stop, but then you got 30-40% air freight. So what we came up with was something that hopefully solves for the economics and the ergonomics. Keep in mind, the drones, the bicycles, you saw all those things. Okay, it snows, guys. It snows. So I don't know what to tell you. I grew up in Pittsburgh. I'm cool. I hope the drones work. It snows, right? So, but people have gone away from the side load or end load, and it doesn't matter to us what it is. But it's because the job stunk. If you change the job at the delivery to what the work really wants to be. If we started, we took all the delivery analysis, all the orders for our customers, and said, this is what the delivery looks like. And then I literally, 7 years ago, on a whiteboard, drew on a whiteboard and said, this is what a truck should look like. It should look like the deliveries. Because up until that point, we were always trying to force the deliveries into what was available. It was either the side load, the end load, or the box, or whatever the case is. But they all were sort of, you can have capacity or you can have selectivity. And not a lot of ergonomic no matter how you cut it. So anyhow, basically in what was that, about 8 minutes? It's a combination of different, of not sacrificing the ergonomics or the economics, and it's taking the goods to the person, which then changes. As I look at the bikes and I look at some of the esteemed gentleman from Estes brought up, where the supply chain starts to run into trouble for us in the factories and the warehouse and on deliveries is the reliance on human beings. So there's fewer and fewer people that want to do it. I think you mentioned that. But there's two dynamics. One, there's fewer people that want to do it. But two, the job stinks. If the job's not so bad, when we had a truck out at the NBWA show in Chicago, one guy came up and said, I want one of those. I said, well, I don't even know how much it costs you. He's like, I don't care. Because if I had it, my guys wouldn't quit. And they wouldn't age out at 35. So they can't keep them. So people are running away from a certain type of delivery vehicle, but it's not the vehicle. The job stinks. If you change the job to match the work and then change the equipment to match the work, not so horrendous. Okay? That's, we're supposed to be leaving questions and answers at the end. Okay.
Okay, while they're shifting, we're going to have a coffee break right here. So, I'm already walking down.
Excellent. Excellent.
Please keep it going. Have your coffee and come back, and we're going to continue and work right into the next panel. So, I'm finding it fascinating. I hope you are as well. So, we'll just keep rolling.
Hello? Is it on? Good morning. I'm Dick Sullivan from Palfinger Liftgates, and my time is up, so thank you very much. I didn't do a slide presentation, and part of the reason for that is that we have a demo truck out at the plant that has 4 products on it, so the best thing is to feel it, touch it, and operate it. But a little bit about Palfinger, second largest liftgate manufacturer in the world, Austrian company. And I've been with Interlift and Palfinger for about 15 years. And what really brought me to Palfinger, I was seeing them in the industry, or Interlift at the time, is that I have a background in aviation maintenance. So when I look at a piece of equipment, I look at number 1, what will fail? Number 2, what are the consequences of that failure? And number 3, how fast can we get it back in service again? So that's what brought me to Palfinger, and the innovations that we've had over the years have kept me here. So exciting product, exciting job. Now, what happens is that it's appropriate that I'm the last speaker because the liftgate was the last guy to the party, and many times without a lot of forethought. So if some of you that are old enough remember Stephen Covey's 7 Habits of Highly Effective People, the first one is begin with the end in mind. So if you're going to deliver the last mile, let's begin with what we're delivering, how big it is, how heavy it is, how many stops we're going to make, and what's going to happen. The liftgate issues that we see, and I do tech services and sales, the issues that we see, 99% of the calls that we get for service on a liftgate is because we have dead batteries, or an empty fuel tank, if you will. So the batteries are the fuel tank for the liftgate. When you size your truck or your tractor, if that truck is going cross-country, you might have 600 gallons of fuel on it. If it's doing city deliveries, you might have 80 gallons of fuel on it. You're sizing your fuel tank to what you're doing or what you're delivering and what your route is. If you have a bigger gate on your trailers, a 53-foot trailer or whatever, if you're making 10 stops a day in beverage or food or auto parts or whatever, and you're running that liftgate 10 times at each stop, that's 100 cycles a day. If you try to do that with one battery, it's going to quit before you get to that final mile. It may quit halfway through. So we try to monitor what we have with some kind of a voltmeter, some kind of a gauge. As they say, the batteries are the fuel tank for the liftgate. If you don't have a gauge on there so the driver can tell what the state is, he doesn't know that he's got to stop and refuel. But what we get into is charging systems as well, and things have changed and changed and changed recently. So if we don't have a good charging system coming from the tractor, if we have no way for the driver to know that that's not working, if we don't have enough charge capacity to take care of the amp load on the liftgate, you're stopping, you got 5-minute shutdown on idle. Most companies, and I would think, Mike, you do that too, when you're running the liftgate, you're shutting the tractor off, 3-minute shutdown. Well, if you're making 10 drops on the liftgate, you're drawing high amperage. A liftgate motor is a starter motor. It draws a lot of amperage for a short period of time. So to make that efficient, we try to make the cycles as short as possible, amp draw as short as possible, but the battery only has so many gallons of fuel, if you will. So if you're taking it out faster than you're putting it in, you're going to have a problem at the other end. And that's where we see it. And then it's monitoring what the deliveries are, where we'll get questions that, well, your liftgate failed. What's the voltage? Well, it reads 11.5 volts. Well, the batteries are dead. Well, that's your liftgate problem. No, but we'll help with that liftgate problem. We need to size the charging system to your use. And we're involved with eNow with a lot of solar. So there's a lot of different solutions. So if we know what your needs are up front, when you're speccing the trailer and you say, I'm going to need a liftgate on it, let's talk about how that liftgate is going to be used. I've got customers that run liftgates 14 cycles a month, total solar, 100-watt solar panel, that's all they need. I've got customers that run 10 stops a day and 10 drops at every stop. Some of them with auto parts are loaded both ways, bringing back quarters and the whole thing. So once we can analyze what your needs are, we can set a sizing system and a number of batteries so that you don't run out of fuel. And then when the trailer gets back, that's where we run into a problem. It'll go through maybe the first day, but then halfway through the second day, when you get toward that final mile, now the trailer's out of service. So maybe you can add a different charging system, a solar system. Everybody knows in here what a road call costs you. So if you spend the price of one road call up front when you spec the gate, you can save 100 road calls down the life of the gate. So those are the things that we look at, and that's I guess what we want to talk about. To get to the final mile, let's do the right things up front. And then after you get that, it gets down to maintenance. And we're the last guy to the party. There's a lot of techs now. We talked about keeping good techs and keeping good things. They're not familiar with electric, hydraulic, and in some cases, mechanical things. So they start at the front of the truck. You got a chassis mechanic. They do a great job on the chassis. They look at the truck body, no dents, not falling off. Get to the liftgate, okay, let's leave that alone and go away. So that's what happens with it. So if we can get the maintenance done, and there's two kinds of maintenance. There's scheduled maintenance and unscheduled maintenance. Scheduled maintenance is very inexpensive. Unscheduled maintenance is very expensive. How many of you fly on the airlines? Everybody. They do scheduled maintenance. That's why we don't have all these smoking holes in the ground, because the airplanes are taken care of prior. Not that there's not incidents, But if you look at the safety record that there is in the aviation industry compared to what we have in automotive, it's much safer to fly than it is to drive. So that's what we want to get to a point of. We get scheduled maintenance, we get the gate sized correctly up front, charging system sized right up front, and that'll keep the truck on the road and prevent the road calls. So, questions? Okay, thank you.
So how much time do we have? 5 minutes. So I got time for 5 questions. Do we have anybody with questions in the audience?
I have a question.
All right.
Mr. Sullivan, predictive analytics and telematics, how does that figure into the future of improved reliability?
We're doing a lot of that in Europe. The technology and that sort of thing in Europe is years ahead of where we are here. Part of the reason that they can do more of that in Europe is everything is running on a 28-volt electrical system. So you can run a lot more efficiently on that. Until we get to, more of that, that's fine. But the telematics that they're using over there, they're doing a lot of things with it. At the Hanover show a couple years ago, we saw where they can, through GPS, they know where the truck is. If we have a lift gate that is the back door, somebody's delivering liquor or something expensive, they program the GPS so that guy has 5 or 6 stops. The gate will not operate. They can't get inside the trailer unless they're within 500 feet of that stop. So there's that kind of thing going on. We have backup cameras that are split to what you were talking about. In Europe, when they have the cantilever gates that fold down, they have a pocket under the dock floor, and they back in with that gate down. And so what they would do before is back up close to the dock, drop the gate, line it up, back in. Now, when they put it in reverse, they've got a backup camera. That splits when they put it in reverse. It has the downside on it. The guy sits in the truck, does it all through the backup camera, and backs into the dock. Then beyond that, if that guy has the same 10 stops every day, he can pre-program. Gets to stop 1, hits the button, gate goes down just to where it has to be to back into the dock. So there's a lot of things that we can do that are being done in Europe to make things more efficient. And we can do some of them here now, but until we get into having more voltage capacity and more amperage capacity, it's going to be difficult. So, and that's part of, we're doing some of those things with the addition of solar too, because solar can add a lot of input that really keeps things going without driver involvement. So anytime you can keep human involvement out of it and make something that works kind of automatically with some kind of a monitoring system, it's a lot better.
Dave, do you have any sense of how big e-commerce is as a part of the overall economy?
That's an interesting question. We're at McCabe, we do market research, and we're doing a study on that right now to try to measure how big that is and how much it's moving. But the real challenge is, how do you define, what e-commerce is? Is faxing an order, is emailing an order, or does he have to place the order and pay for it with a credit card online? I mean, that's part of what we're trying to measure now is what pieces of it are really e-commerce and which ones aren't. So I'm not sure how, when we ask on surveys to fleets, not a lot of repair parts for trucks and trailers, are being ordered that way, even though it gets a lot of visibility. We don't see a lot of that of what you might consider the traditional e-commerce, where you go online, find the parts, submit the order, give your credit card. But there's a lot of electronic data interchange that's been going on for a long time between, the OEs manage, a lot of OEs are managing their own dealer inventories and doing the ordering for them for stock orders. There's dealers who are managing fleet inventory for parts. So on the parts and service side, there's a lot of electronic information transfer going on. Now, I don't know if you call that e-commerce or not, but we still haven't figured out how to dematerialize the part and send it down the wire and put it back together at the other end.
I guess I
I guess I don't know the answer today. Probably in a month or so, I might have a better idea how fast it's going when I finish the research that we're working on. But, you know, the challenge that I have when you think about in the industry we are in fixing the part, you know, the truck is worth a lot of money. And, you know, if it's a scheduled maintenance and you know about it, you have the parts, the truck goes down and you fix it. All the unscheduled maintenance that, you know, we're talking about, you know, you got a truck down, it's, you know, if it's on the side of the road, the ice cream is melting, you need to get it back going again. And if you don't have the part, it costs a lot of money to have that truck, you know, sit there. And, you know, you talk to, and we talk to people like Swift who, you know, they'll say, you know, the truck goes down on Friday someplace in Denver, and I need to know, you know, what happens on Friday. Am I going to, you know, and the dealer says, I'll fix it. I'll tell you on Monday. And they go, I don't need to know. I need to know now. I got a driver. I got a load. You know, I need to know if Monday morning you're going to have the part and it's going to be gone, and I'll leave the driver in a hotel. Otherwise, I'm going to send the driver home. I'm going to send another truck to get the load, and, you know, if you're not going to have it till Wednesday. So to order online and wait very long, which means to get that part there in a reasonable time frame, you still got to have the part close. You know, I mean, that's why Amazon, I think, is building all the warehouses there. You got to have the part pretty close just to get it from the warehouse to the end user, you know, in a reasonable kind of time frame, if you're talking about repairing the kind of equipment that, you know, we're running here. So, yeah. Right. I got a question that I can, go ahead.
We don't have a firm number, but we're hearing in 30 to 40% category. Yes.
Follow-up question, basically for Greg and for Bill combined. We have infrastructure in the freight distribution system now that is based on dock height. Factories, DCs, freight terminals. And yet the challenge, it seems to me, is to go from there to ground level height, or what you call the end in mind, okay, the final delivery. I guess this is for you too, Dick. Dick solves it because you can load at dock height and use the elevator to go up and down. Your system automates and brings it down to dock level, and your system helps in and out at the dock level system. But then yours also showed loading at the ground level system in that unitized fashion. We don't have the infrastructure to do that. So maybe you guys need to get together and figure out how we can take the existing dock level infrastructure and come up with a solution that gets us to the end in mind at ground level.
I think that that's a great point, because if you saw that picture at the last, you got a dock height at the back, and you've got what we're calling that 39-inch or so, that ergonomic hotspot, belt buckle level for the average human being. And what happens is, you know, when we do all the routing studies and we do all the cost of delivering, and we've been saving people money in the warehouse for a long time, but it's pennies compared to taking a driver and a truck off the street. So if you've got 3 routes or 3 delivery routes and they become 2, there's a fair amount of money that you can invest in a piece of equipment or the infrastructure, because even that upfront investment is offset by the annual operating cost of that one route that's no longer on there. So getting the product back down at that level, I think is critical, depending on what your drop size is. And I think someone else made the point is determine what the work is. Just like, you know, we determine what the work is, and then we decide whether I need a spade, a shovel, or a steam shovel. A lot of customers, and the question came up on e-commerce. I bought a disposal the other day. I went to a big box store, right? The guy that works for me ordered on Amazon, came to his house. I'm like, you can do that? He's like, yeah. So that disposal didn't go on any box truck, ever. It came to his house. So it's gnawing away at the over-the-road transport. When we do network analysis for people to determine how many factories and warehouses they should have coast to coast in whatever country we're in, one of the inputs to that is a service radius. So if you're locked into, I can only get 8 stops a day off, so then that draws more DCs or more close based on your desired response time. If the vehicle design allows you a greater service radius, it literally will impact the number of DCs and where they are. So taking the vehicles and designing it to the work, I think it's going to be a combination of at dock. But when you say, there's a distribution infrastructure at dock height, 100% true. But if you think about a lot of these companies, they might be consumer goods, they might be packaged. They're picking the belt and they're conveying it down to the truck and they're floor loading these things. And I use the example about the one home package delivery. This guy builds all their DCs, a construction guy I know. He says they're putting 20, 30 million in automation, and you know where it ends up? In that guy's hands, and he's putting it on the floor of a semi, and that jump shot at the end to get the last little bit of cube because they think they can't afford a pallet. The other thing you see in manufacturing companies is they spend all this money to make all this product, and they put it on a pallet at the palletizer. It's then forklift, double wide or single wide, and put away or AGV over to an ASRS. But you're not buying a pallet of anything. You're buying a case of something. So the entire palletization step at a lot of these DCs that requires that dock level height, it doesn't necessarily have to be. There's less and less call for unitized loads than there ever was. So if you think about it, they spend, like, if for an automated case picking system, they're spending a lot of that money is on the palletization, the end effectors, and the robots to make all the different, tie highs. And then it's forklift over to a rack or storage or an ASRS. Then it's forklift to the truck, and then ends up on a two-wheeler. So if you can bypass the palletization step, from a DC design standpoint, it changes the economics. Because somebody will be able to take product and leave it at the case level and take it to the truck. So it may be palletized in the warehouse, but then it's depalletized if necessary there. That pallet that goes on a lot of these trucks, whether they be side load, end load, or whatever, never goes into the store. Or if it goes in, it comes right back out. So I would agree that there's definitely that dock height, and that's the infrastructure we have. But it's an old infrastructure that was meant for moving furniture and unit loads and full pallets of Fruit Loops, not 15 cases. And now everybody wants 15 cases. The pallet doesn't have any value to the milkman. And the supply chains we're seeing are going more and more towards the milkman.